Lab 2. So, introduction. So the purpose of this lab was to use the same procedure that we did in lab 1, but instead to treat the tape as a material of evenly distributed charges instead of a single point charge like how we did in lab 1. The fundamentals that we will use is Coulomb's law, Newton's second law, and the law of superposition. And the goals are to calculate the magnitude of the gravitational and electrical force acting on the floating tape and to create a computational model that visualizes the forces acting on the tapes. All of this being shown as a line of evenly distributed charges on the tapes. So the assumptions that I made in order to make this possible was to treat each tape as if it's of equal charge and that the charge on the tape is actually like evenly distributed throughout the entire tape and to ignore air resistance. So here is my code. So here we started off with the constants, and here is the mass, and then here's like the where you kind of like just like guess like the estimated net charge on the tape, so that you can balance out the gravitational force and the the electric force. And then over here, this function describes the electric field on each tape, and then this function right here, it 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 it's what creates like a uniform total charge for the line segment. And then here we create a top tape and a bottom tape. And here I for my n I chose it to be 10 because that's how it worked best with like the scaling that I used. Here in this scaling, it took a while to like play around with it because it would like either like go off the screen or do some really crazy stuff. And over here I did the same, just playing around with the scale of like the arrows and the circles. Uh, Here is like where the for loop begins for all the iterations to do, which are acted on each bottom and top tape. And here's where the net and where the net electric force and gravitational force were calculated on both the top tape and the bottom tape. And then here is where the arrows for the electrical force vector and the gravitational force vector were created to go away from the tape. And then just these bottom lines of code is what prints out the values of our forces. So here is the models that I came up with in using GlowScript. So this first one is the accurate one where I guessed for the Q value so that the gravitational force and the electric force roughly balance out, which as you can see these two values are very very close using this value for Q. And then this one is is an example that I did using, because this is the value that I got for Q from lab 1. So I tried this out at first to see what it would give me. And as you can see, the magnitude of the gravitational force is pretty far from the electric force. And then here I compared it to my actual lab 1 using the value that we got from lab 1, which is 1.96 e to the negative 3. So here I have three different models to compare to, and down here is my link to my code. Conclusion. So how are these results different from a point charge from lab 1 to an evenly distributed line of charges? So um, pretty obvious that these results are a lot more accurate when modeled as a line of charges instead of just a single point charge. And now, why do these results differ? So, with more data points, such as an evenly distributed line of charges, it's just going to be a lot more accurate, just generalizing it instead of a one whole point charge, because we have a for loop in our code that accounts for more data, and more data just means more accurate with a lot more iterations instead of just one straight shot and treating it as a point charge. So conclusion questions. What if we had modeled each of our tapes as a single point charge like in the previous lab? Well, um, it would underestimate the value of the charges of each tape, and I calculated an underestimate error to be 7.382%, comparing this to the previous lab. So this just goes to show how much more accurate we are now compared to when we did it as a single point charge. And now, why do these estimates differ? And I said that the value I calculated in this lab is more accurate than my result from lab 1, as I discussed over here in the previous question. And they differ simply because we simplified the assumptions made in lab 1 uh, by treating the entire tape as a single point charge. And this simplification is just what leads to a more generalized and rough estimate of our answer, whereas this one with more iterations and loops, it's more accurate and gives us a better uh, calculation. And that's it.